Okay, to find out how many students can see the images of the other two, we have to determine the range of vision of each student. Okay, so what I have to do, right, is to draw a line to one end of the mirror, and then make sure that this angle is equal to this angle, and we draw this line. Okay, so we will do the same for the other end. Measure this angle, make sure that this angle is roughly the same. So in this case, the light ray will go from these two ends of the mirror and reflect into the eye of student X. So that means any point that is from here to here, student X will be able to see. So student X can see student Y and Z. Okay, let's do the same thing for student Y. Okay, student Y, we have an angle somewhere here. So for student Y, his range of vision will be from this point to this point. So he will be able to see X and Z. Okay, now let's do the same thing for student Z. Okay, student Z vision will be from here to here. So it covers student X and Y. That means student Z is able to see the image of the other two as well. So the number of students will be 3. Okay, when the eye views a distant object, the object distance, it will be greater than 2 focal lengths away. So if you are familiar with the ray diagram of lenses, we know that the image formed when the object distance is greater than 2f, it should be real, inverted and diminished. Answer B. To answer this question, we can use the mnemonic funny people are lame, where F stands for frequency, P stands for pitch, A for amplitude, and L for loudness. So basically this tells us that the frequency is related to the pitch. The higher the frequency, the higher the pitch. And amplitude is related to loudness. The higher the amplitude, the higher the loudness. Okay, so now which sound is both loud and low pitch? So if it's loud, it must have a high amplitude and also a low frequency. So in this case, a large amplitude, it will be A and C, and a low frequency, A has a lower frequency than C, so A should be the answer. If you were to use a larger current, it will produce a stronger magnetic field. So it could either be C or D. And when the current direction is reversed, is in the opposite direction, the field direction, it will reverse as well. So the answer is C. The diagram shows an electric bell. So this bell is going to make a ring sound. So how does it do it, right? When the switch is closed, the current will flow through this part down to this part, and it will flow into the solenoid. And the solenoid will be magnetized. So once it magnetized, it will attract this part, which should be made of magnetic material such as iron, so that it can be attracted. So when it's being attracted, it makes a ting sound. So when this part is being attracted, this whole thing will be pulled to the left, and the contact will be lost, there will be a gap here such that the current cannot flow through. So when the current cannot flow through, this will lose its magnetism, and this R should be made out of something like a spring such that it will spring back. So when it springs back, the gap is closed and the current will flow through, and this becomes a electromagnet, and it will attract Q such that this thing here will strike the bell. So this process will keep repeating such that you will get a ding 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 ding. That's why you get a ring sound. Okay, so in this case, Q must be a soft iron. R has to be something like a spring, which is a spring steel. And P, in order for it to be magnetized, it has to be made of soft magnetic material, so which is a soft iron. Hence we can deduce that the answer must be B.